My name is Sidhartha Dash, or Sid Dash for short. I'm from Chartis Research, and we're going to today talk about the challenges and dynamics of operational analytics in the energy value chain. This is a challenging and often rather complex topic, and for that we have an expert, Nima Safian, to help us out. Nima, if you just quickly introduce yourself, and then we would jump in.
Hi, Sid. I'm Nima Safayan. I am in Calgary, Alberta. I work for a Canadian oil company called Chartis Energy. We are, I don't know, third largest Canadian producer. We have network of assets and refineries. My official title is VP of Value Chain Optimization, which I'm kind of my group effectively is in charge of optimizing the barrels that we put into our refineries and the products that we sell to the end customers, and commercial optimization along the way, in order to generate as much value from our barrels and from our assets as possible.
Great. Thank you. So with that, we will dive in now. I mean, as everyone knows, operational analytics have been growing sophisticated. There is a greater focus on optimization, greater focus on forecasting demand and load, greater focus on predictive analytics. So we're going to examine some of these issues and aspects. I mean, specifically, Nima, one of the things I wanted to understand from you is which kind of analytics do you see sort of having the most potential in your space currently? I mean, things such as advanced optimization, AI, predictive models, or some kind of option theoretic approaches, etc.
I would say that depends on the application. I kind of think that, I'm of the view that there's no one solution fits all approach. Obviously, when you want to optimize your physical barrels or, physical assets, obviously there are very known methodologies such as LP modeling that has been used. There are somewhat, opportunities for improvement in that area. We can kind of get into it. But at the same time, let's say when you're kind of contemplating a asset project, I think there's a big role for option modeling because, that's really like trying to understand both the intrinsic and extrinsic value of these assets to support a better decision making. So, ultimately all models are used to improve decision quality. And depending on what type of decisions are we making, let's say, type 1 decisions, micro decisions, or we're making strategic decisions, there could be different tools deployed to solve that problem. So I would say it's a portfolio approach and multi-model approach to decision making.
Of course, horses for courses, if you will.
Yes.
But sort of going into a specific area, i.e., optimization, I think you mentioned that. Optimization is something that has been evolving over a long period of time. We have obviously the choices of using classical solvers, some of which target one specific area, linear programming, integer programming, and go really strong and deep into it, versus some of the more general heuristic approaches. From your perspective, A, is there any advantage? Or B, are there advantages and trade-offs in both sort of approaches, if you will?
I would say so. Ultimately, at the end of the day, with optimization models, you're trying to mimic reality. In some ways, there's a new term they always say, digital twin. I mean, it comes from engineering, but really, you could look at it from your logistics operation as well. You could create a digital twin of your physical twin, which is your actual operation. The reality is the actual operation is quite stochastic. It's not you don't operate in a deterministic world, both from your operational perspective and from a market perspective. So in some ways, I would say LP models, linear programming models, are a very gross simplification of a very complex reality. So it's good. I mean, in some ways, it solves a problem. It simplifies effectively your decision space. But at the same time, it might introduce other complications, meaning that it simplifies it too much. You effectively assume a very deterministic future, you plan around it, but then the reality is quite different. So one improvement I would say on the traditional sort of LP models could be stochastic modeling. In some ways like dynamic optimization, or in a different world and using different tools. People kind of talk about deep reinforcement. Those are the things I would say. Probably from an operation perspective, I kind of see a lot of scope there because they kind of support the different math behind the decision model.
Absolutely. And not only that you have stochastic and non-deterministic inputs from your environment, which is challenging enough, but also the market keeps on shifting massively. And to that extent, do you see the fact that we now are having greater volatility, more complex markets, any issues of injecting that into your modeling, any challenges thereof, yeah, just how do you think that impacts your modeling?
Yeah, I mean that's again like it becomes another source of the state you're in, like in some ways taking from the uh, deep learning sort of approach. You have state, action, and reward. Really, your state is quite unknown. At the time that you make that decision. There's many uncertainties even around pricing. I mean, you kind of think about, when you think about pricing, you always think, okay, I have market prices available to me on an exchange, but in a lot of physical markets, that's not the case. So that's a big unknown. The fact that you don't even know, you cannot even say with certainty what state you're in is a big problem, and that injecting price into this is definitely going to have a significant source of error. However, though, I kind of caveat this by saying that this is not something that's totally new. I come from a trading/risk management background, and this is something that a portfolio manager or a trading book always grapples with. And there have been developments of certain tools, not necessarily software, but certain approaches that kind of take into account that uncertainty in the decisions that we make. And we kind of talk all the time around risk reward. You have like something like VAR system, you do stress testing. So you supplement your decisions with what if scenarios and uncertainties that are inherent in your portfolio. I would say, like, I kind of think that maybe some of the evolution when it comes to logistics and dealing with physical system should take from financial risk management, take learnings from financial risk management.
Specifically, I think the idea of what ifs and scenario management from the markets and so on and so forth. Do you think that would be the kinds of areas they could take and learn from the financial risk universe, if you will?
Most certainly, I think there's a lot of learning there, and it's very much like when it comes to a portfolio, you inherently know that there's a lot of volatility coming from the market. You don't necessarily view a deterministic future, and I think even that sort of philosophy around your assets would be quite helpful into almost developing a more realistic outlook and realistic set of decision support systems in terms of how you run your business.
The other sort of somewhat linked, I mean, I think there has been a fairly substantial amount of theory. You mentioned option theoretic issues. There's been a substantial amount of work around real options and application of option theoretic views on physical assets, particularly in the energy space because of the market-oriented link. Do you think we have a mature view of that, or do you think that you still need to have more specific option models for energy sort of situations, or I think you think there are several areas of potential improvement there.
Yeah, certainly there is. And, I kind of view option modeling as from two perspectives. One is the actual math behind it, which is quite advanced in some ways. There are very specific energy models that you can kind of pick up, like from a price process perspective and so on. But also there is a bit of a philosophy behind option modeling. The notion that optionality has value. The notion that by owning a physical asset, you're effectively or long a volatility of the spread. Like things of that sort, becomes quite valuable from a strategic perspective. I think you have to do the work, you have to do the calculation, incorporate option valuation in your, when you make a case for, buying an asset or shorting an asset, going long an asset. That you have to do the work. But at the same time, I think ultimately the philosophy behind flexibility has a value, and that value is quite important when you actually start thinking about assets. I think that by itself has far more value than the actual end number. So I'm kind of like I think it's a great sort of way of articulating the value of physical assets, but at the same time I view the real optionality as more of a strategic view that you have around your portfolio.
No, of course, I think I would agree with you that the idea of options as a framework, as a way of thinking, is just as valuable as the precise price that you, or the second delta or the omega that you generate out of the option derivatives. I think that as you absolutely correctly articulated, the idea that it has flexibility and there are flexible choices, I think is probably where it is most valuable. I think everything that we have discussed so far, and every sort of perspective you brought to the table, suggests that the optimization infrastructure, the analytics infrastructure in the oil and gas industry is actually quite mature. It's not these are not new elements. So I think one of the interesting things that we think about all the time is how do you bring in things like AI and sort of the newer set of models? How can they be how can they intertwine with the existing infrastructure, existing modeling framework? What's the best approach, or just do you replace everything?
No, I'm not a big believer of that. We got to implement one AI solution that basically does everything. I think there is a lot of application around AI in terms of aspects of your optimization, meaning that, let's say that you have a uncertainty around forecasting a demand of a certain product. You could use AI, you could use time series forecasting, improve it using AI, like neural networks, and they get a bit slightly better forecast. You could do that with, let's say, run a reinforcement learning. So when you optimize your assets, you're looking at multi-period rather than single period timeframes. So these small decisions that you make around your improvement of your forecasting, improving around the information that goes into your sort of decision-making framework, I think individually by themselves might not transform how you run your business, but as an aggregate, all of a sudden improves your decision quality as a whole. I kind of see these things as a bit of a incremental and gradual sort of approach rather than a one solution that comes in and runs your business. I mean, in a sense, even if in a hypothetical sense, if you had an AI that was far better than your operators that to run your business, I don't think there's enough trust in black box solutions for people to adopt that. So, you know, they would basically have a very fancy tool, but they wouldn't necessarily act on it, because ultimately at the end of the day, you need people to believe the numbers in order to act on them, act on those decisions. So even in that hypothetical scenario where we had that capability, I think it would be very difficult to convince people to run their business off of a black box model.
Well, thank you. And I think with that, we bring our discussion today to the close. I think we could have carried on the discussion for many, many aspects of the evolutionary world. As you rightly put it, it's an evolution, not a revolution. And we will hopefully be discussing this evolution in this forum and other forums later on. But thank you very much. And so as you see, I think from Nima's point of view, you see key issues around flexibility, evolution, and the transparency and the ability to understand your models, as well as the overarching framework in the way you think about them. Those are the critical issues, but you know, obviously we couldn't capture the world in the time we had, but hopefully we addressed a few significant challenges and issues. Thank you.
Awesome. Thank you very much, Sid.
Thank you.